Okay, so today we are gonna look upon some examples of random forest and some topics, or basically say some terminologies and hyperparameter tuning like cross validation. Okay, so first we'll start with random forest, and in that too we'll be looking to what classification problem. Classification. Okay, so what basically classification is, we'll consider this an example. Let's say we have to classify certain plants. Classify plants. Let's say as input, what we have petal length, sepal length, color, and texture. So these are basically what are feature 1, feature 2, feature 3, and feature 4. And based on that, we have to get our output as plant A, plant B, and plant C. Okay, so this is what our output. So how things work? Basically, we know that random forest is made up of decision trees. Okay, so at each and every node, let's say this is our tree, and at each and every node we take a decision whether to put this plant in this side of the tree or that side of the tree. Basically, we have to make certain decision based on what we have: feature 1, feature 2, feature 3, and so on. And this process will happen up till you get a pure split. Okay, so how can we calculate this pure split? With the help of entropy or Guinea impurity. Okay, and one more question which comes to your mind, that which all feature we have to select first for the classification, whether we have to make decision of F1 here or F1 here and F2 here and F4 here, because there are multiple features. So where to start? So for that we have one more parameter called information gain. Information gain. Right. So this is the feature we'll be using. Whatever the features, information gain is higher, we'll be taking it as first basis or basis of our classification, right? So this is the basic working of decision tree. Now there comes a problem which we have already discussed, that is called overfitting. So we have discussed that what is overfitting, why overfitting. Okay, but how to, the question comes is how to avoid overfitting. Avoid overfitting. So let's say this is a tree, and what will happen that this tree will keep on growing until it gets a pure or impure split, right? It will keep on going until it gets a pure split, basically either yes or no in case of binary classification. So this will lead to overfitting because your model will be training too much close to the training data, but it may not perform well on testing data because your model is not generalized. And in machine learning, what we want a generalized model. Okay, so to avoid this, we have a technique called pruning. And basically there are two kind of pruning: pre-pruning and post-pruning. So what pruning is, basically in simple terms, you have to cut down your tree at certain level of depth. Okay, let's say you cut your tree from here and you will be taking all the decision made up till here. So this will avoid overfitting. Okay, so this basically this limits the maximum depth of the decision tree, right? So max depth. So this is a hyperparameter which you can pass while defining your random forest classifier or regressor that will be looking in the practical implementation. Okay, now we'll move to what ensemble techniques, that what all things we have to consider while we work with ensemble techniques, because we know that random forest is an ensemble technique or basically bagging in short terms. So random forest is a ensemble technique. Okay, so here let's say we have a data set. This is our data set. These are our features, right? And let's say f1, f2 and up to fn, and these are our data entries. Okay, so and in case of random forest, what we'll be having, we'll be having multiple models. So what this multiple models will be doing, they'll be predicting output. Let's say 0 1 1 1. This is model 1, model 2, model 3, model 4. Okay, so now the question comes that how we'll be feeding the data. So how will we be feeding the data? We'll be randomly distributing data based on what parameters? Based on row sampling plus feature sampling. Okay, so this is basically what happens in the bagging. Okay, so this is the strategy of bagging technique. So the question is that how row sampling plus feature sampling happens. Okay, so there are two ways basically. Either you do it mathematically, math, or calculatively, or you can do it randomly. Okay, so basically there are two ways. So this is what we call permutation and combination of the row sample and feature sample. Because let's say this is your data set, so and this is your features basically. So you can pick out any random features and some random set of rows and give it to some model, and it will predict the output. So this is what a random feature selection in simple terms. Okay, so now we got the idea that what random row sampling and feature sampling is, and basically there are two ways, one this and another is this. Now how to evaluate the performance of model. So there is one technique, or which basically you can say methodology, which is called cross validation. Okay, so before giving a definition or what basically cross validation is, let me remind you of what we already know, that is called train test split. So in machine learning, if you have run a simple model, even linear regression also, you might have data set. Let's say this is your data set, and what you tend to do, you divide it in test and train. Let's say in some random ratio, train and test. This is our methodology, and this can be achieved easily through any Python library. So this basically does what, for example, this is your data set. You will take some of the things and save it for training. Okay, and remaining thing for testing purpose. Obviously, in the most of the time, what we have training data as more and testing data is less. So the problem here is that what we face is that our inputs are not overall covered. Let's say this is our data set. Okay, this is our data set, and let's say what we did, we just picked the above rows and gave it to training part, right, and the remaining rows to testing part. So what will happen, our model will not be able to learn anything from this testing part. Okay, will not be able to learn anything from this testing part. It will only predict the output based on this. So there comes a problem. Okay, so how to resolve this problem? we can use cross validation. So let me diagrammatically show you what cross validation is. Let's say this is our data set. I am drawing multiple instances of same data set. Okay, now what we'll be doing for first iteration, we'll be taking, let's say, this part of the data set and make it test and remaining as training. Okay, now for the second iteration, we'll be taking this as test and making as remaining as training. And for the next iteration, we may take this as test and remaining as training. So this is what we are doing. Basically, we are not leaving any part of our data set to be trained or feed it to model. So this in turn will do what? It will cover whole data set, and even testing is possible. So what is the benefit here? The benefit here is that we are not leaving even a single row. Okay, even a single row for the training of data set. Okay, so this is very beneficial. You are not wasting your data. You are just utilizing it the best way possible. Okay, now this is one way to represent cross validation. Okay, there is another thing. What we mean by cross validation is that, or basically that is also a cross validation. For example, you have a model. This is your model M. So with this model, there are multiple parameters associated. Let's say in terms of decision tree, you have learning rate. Okay, not learning rate. Basically, in terms of regression, if you talk linear regression, you have learning rate. Okay, you have other parameters that what will be the percentile values have to take. You'll take the value. For example, there are outliers in the data set, so you'll be doing what? You will take 95 percentile as the upper bound, F5 percentile as the lower bound, and remaining all you'll be discarding. So these all hyperparameters and there might be some other hyperparameter that whether you'll be adding some bias or not, if it's regression loss or regression. So so now the question comes that how you decide this which hyperparameter to take, like which alpha should I take? 0.1, 0.0001, or 10, or even 100? What to take? There is the question. So you can like basically get this by with the help of cross validation. Okay, so how? There are two ways, okay, of cross validation. There is one method called Gridsearch CV, and another is randomized search CV. So these are the two methods which you can say are used for this purpose, right? So to avoid this, like this problems, what we do, Gridsearch CV, do it mathematically. It will pick out and try best possible combinations, which it returns, like let's say it returns alpha equals to 0.01 and some other parameter as like 30, let's say random parameter. So it will be doing it mathematically and optimizing it and using different algorithms to achieve the best possible set of combinations. In randomized search CV, will be picking out random values and testing, and if it increases our performance, we'll take at this model. Okay, so this is how grid search and random search CV works. Okay, now before we move ahead, there's one last thing I want to touch, that is called confusion matrix. Okay, confusion matrix. So I'll not go with the mathematical representation or whatever with the confusion matrix. Let's say just consider a real life example. Let's say we have a binary classification, and in binary classification we have output as yes or no, or basically true or false, or 1 or 0, whatever you represent. Okay, so let's say it's a spam detection problem. So for spam detection, you have spam as 1 and ham or not spam as 0. So this is how you will make your confusion matrix, right? Okay, so let's say we make a confusion matrix like this. So in this side we'll be taking our actual thing, actual, and this side we'll be taking our prediction thing. That's it. This column represents spam and this represents ham, which is actually predicted by model, and this column represented spam, which is predicted by the model, and this is ham. Basically these are the real thing, real outputs, and this is our predictions. So how confusion matrix works, that if actually the output is spam and model classify it as spam, then it is what? True. Okay. If actually the model classify this as ham and also in real the output also is ham, then it is also correct, but otherwise it will be false. So what the only thing you have to keep in mind while you are studying this confusion matrix, that whatever comes in the diagonal of confusion matrix give you correct outputs, and you have to focus on this in most of the cases, right? So this is how confusion matrix works. In next we'll be doing what? We'll be looking on the topic called practical implementations of random forest using Python and sklearn. Okay, so see you next.